So for our next demo, we want to go from provisioning into day 2 operations. And we really want to show you how infrastructure as code and the basic building blocks that we've already been using can be expanded into ongoing operations, because really that's where the systems get to scale. And so we're going to show you how we're complying with security requests using ad hoc Ansible runs. And we're going to work through infrastructure improvement using composable Terraform and drilling into how the Terraform brokers work. For this demo, I am Rob Hirschfeld. I am the Chief of Platform Operations. I'm newly hired to Bank N, and I'm ready to help bring all sorts of infrastructure as code to the organization.
And I'm Greg Althaus. I'm, again, a bank because I'm Vice President of Platform Architecture, and I brought RackN's digital rebar platform into the bank. Rob, you've returned.
I'm back, but don't panic.
Okay. Did you bring your whiteboard?
The security chief called me up and has a security issue, and you don't have to worry about it because I already started whiteboarding out the solution for you.
No.
And we're just going to, right? So we're going to run a whole bunch of stuff. This work order thing looks really cool. Can we just like set up a whole bunch of work?
Okay, wait. I think security at least copied me on the email this time, so I think I know what's going on. How about I just show you what we're going to do, okay?
Okay.
Security said that this vuln1 vulnerability is here. So they went and created a content pack that is available already. And so they provided a bunch of blueprints, which, like I said, are a bunch of tasks that they've already set up that we can run. So they've got a detection task, a fix task, and then for some reason they felt they needed to do a create task. I don't know. But anyway, so what they said to do to immediately fix it is they just need to run their playbooks. And I'm like, oh, okay, we can do that.
Digital rebar runs playbooks.
And again, we kind of gave them access to this so that they could do it themselves. But what we'll do is we'll go to the blueprint and we'll go look at the detect blueprint. In this case, we can see that it's got a task that it needs to run. And in this case, we can choose to apply it to all of our machines. So what I'm going to do is I'm going to select that.
So I'm at the manager. I can see machines.
You can see all the machines everywhere.
And I can access them?
Yeah, and they already made sure that all of the downstream endpoints objects were updated so that that content pack was available to all the downstream systems at their approved level. So I'm going to run those. So we're all running those in parallel.
Tell me when you're going to start it.
I did. It's already done.
Oh.
It ran. So let's go see. Oh, wait, it failed. What happened? Let's see. Oh, they have tools we didn't have installed. All right, let's see. I think they provided a blueprint for that too. Let's see. Where is it? Security tools install. So in this case, I'm going to do this and I'll apply their tools. So now it's all running. It's running in parallel across all the systems. So each system has chosen to pull some tasks that it realizes it needs to do and is doing those all in parallel. So the tools are getting installed. Now, what I really need to do is talk with security, because what they really should be doing also, not just providing these, is providing, since they provided the task, we can add that to the existing deployment pipelines so that it becomes part of our build process, that this is always run as part of the installation process.
So their tools would actually just be added into the pipeline? So they just wrote the work order, but we can make it part of the provisioning pipeline.
Provisioning pipelines by injecting it at the post-install parts for the processes.
That might mean that the CIO doesn't page me as much. That
would be, well, especially since it turns into paging me. So now that I've got most of the tools installed, okay, it looks like they're almost all done, getting there. And the work orders, once the machine's installed, we put it in work order mode so that it can take additional work orders and then they can be queued up and scheduled. The other thing that security should do is use our triggers, and we can define a cron-based trigger that can generate and run blueprints against subsets of machines at scheduled times so that they can run an ongoing detection of if vuln1 comes back.
That would be amazing. Okay. We should definitely show them how to do that.
So, and they can actually do that as infrastructure as code, because all of the objects in the system are part of that process.
So we could add that trigger into the site definition, and then when each site comes up, it would include the security scanning vulnerability trigger, and
Yes.
we wouldn't have to do anything except include it in the base setup.
Yep.
That would.
All right, so now let's run our detect workflow and see what happens. So we're going to run the detection, and we're off and running. Notice in this case, there's still some installing tools.
That makes sense.
So
We have to
with
worry about the order of things.
Yeah.
It's important.
So we'll do that, and it looks like they all ran their detection.
So how do we know what?
Well, let's go see what needs to fix. Now, as part of their task, the team added a dynamic parameter that gets added automatically to the rest of the system called hasVuln1. So we're going to check to see which ones actually had it. Oh my gosh, all the machines seem to have it. So let's fix it. So now we run the same fix. The work orders will run once they're complete. We'll go rerun. Okay, it looks like everything's caught up. So now we'll go back to the detect blueprint. And wow.
So we've been able to mitigate, find, detect, mitigate this across our whole fleet from the management infrastructure.
That's right, in parallel. So we've done 30 machines all here at the same time or so.
And then if I was at one of the edge sites, would I see this activity also?
Yes, so the edge sites can actually see the same work orders. So each of these work orders that are getting run, these little castle icons indicate that they're not running locally. They're actually at the retail dev site. So in this case,
that means if we were disconnected, that site could still
do its job.
operation.
That's right. Cool. So now we go see if there's anything left to fix. Do the same filter. And in this case, it looks like the two that are running behind didn't quite get fixed yet, but
we can keep an eye on those.
I'll
let the security team know that we've got things going.
Okay. So that's using our work order system on existing already deployed infrastructure. And you were wondering like what they define their Ansible in their security tree. So over here, as part of the process, they defined a set of Ansible playbooks that they actually run.
No, okay. It's nice that they were able to use the tools they're used to using. So
yeah. Okay. So I think we got that covered. Okay. So what are we solving now?
So I just got a text from the security team again. They're really happy, but that opened up their queue and now they're doing some more analysis. And they said our Linode broker didn't use firewalls. And they really think we should be using the firewalls. It's a new feature for Linode, and they want us to use that in their building. So I put together sort of how.
Okay, just stop. Let's go look at how a broker works. So you said Linode. I think I saw a product announcement from RackN about that. They were talking about some updates to the underlying brokers. So the broker for all the clouds use Terraform, and they define dynamically a set of Terraform templates that get expanded and built into Terraform plans. And they let you just put a raw plan in if you want, but they also let you do their template injection and stuff. And so they have a bunch of defaults.
It's like composable Terraform.
And so it's composable Terraform. So these are templates that the system renders in place to build a plan that then generates the actual.
So we just need to write a firewall template.
No, I think actually RackN has already made that. They didn't make it default because they didn't want to break existing things in the field. So let's see. Yeah, okay, so here, the firewall script. So you can see it's got its normal kind of resource construction that you're used to in Terraform, but it has parameter injection so that you can do dynamic controls of whether you're adding or creating or moving or defining the ports that you want to open dynamically.
Oh yeah,
injecting it into the Terraform plan so that it gets built and then controlled, and then that gets stored on the cluster so that it can be maintained. So if I go look at my cluster here, I can see like this one I was using Terraform earlier, or it used earlier.
There's our Terraform plan information. Yeah.
Mm-hmm. And then the various content pieces. And then I ran this one in debug so I could actually see what it looks like. And so here's the actual Terraform plan that we used to spin up the Ansible cluster. So it dynamically connected to
so there's
Linode.
No
You can actually see all of it, how it got built. In the case of the Linode one, it would then inject the firewall rules into the positions before the machines were created.
That's awesome.
So that's how Terraform can be injected into the system to manage various cloud infrastructures and other components.
So before you move on, that playbook, I'm curious as to maybe dig in a little bit more and see what that looks like. Like, is it just a simple script that it's then going out and running on each of those devices to check for something, or?
Okay. Yeah. Okay, so in this case, there's two sets, or very simplified because I was writing it fairly quickly. But in some regards, right, in this case, it's just your standard Ansible. The tool script is written as a bash script that knows how to install Git and Ansible. So that ran on the systems and installed the tools. In this case, this is the Ansible playbook that it pulled and ran. If I look at the actual task that was created for it, in this case, we'll just choose one.
And while you type, you can actually pull Ansible from Git, from build it as templates. There's many ways to inject Ansible into the system.
So in this case, right, I just pull the repo and then I run Ansible playbook local to run it. Okay, so that's in a simplified example. In the case of the kube spray stuff, for example, that has a very huge dynamic construction. So in that case, it actually queries the cluster to say what machines are where, what should be control nodes, what should be, builds a dynamic inventory, lets you inject a whole bunch of additional parameters, and then runs Ansible within a context with the kube spray playbook embedded in a container running as the cluster. And then it goes out and runs Ansible remotely against all of the actual worker machines, virtual machines that it needs. So you have both forms of operation of Ansible that you can use. Okay. So in that case, the cluster setup made sure SSH keys were available and stored in RackN so that when Ansible needed to be run, it could then pull those keys in and have access to a control.
And it's worth noting the tasks, because of the way we decompose automation, the tasks that you would do are the same whether you're doing a workflow to build something or a work order to maintain something.
That's right.
So there's a very high degree of reuse because really, the automation shouldn't be that different, even if the mode of operations is different.
Yeah, and I like that, I guess automation aspect of things where you can use it not only to deploy, but to also run checks and stuff like that. So that really intrigued me.
Right.
Yeah, it does feel like what you were talking about there about all the componentry that lives underneath it. There's a lot of detail buried in that. Like there's a lot of work gone into making all of those individual components actually work.
Yeah, the nicety though, from our perspective is that's where the reuse and rebuild comes in that you can continue to grow them and then compose them. It also helps in validation and testing in the sense that most of the tasks are actually very small to find. And what we didn't show is that we're building job logs for every single task execution. So if you're familiar with Chef or Puppet in the history, they would generate huge manifests of logs and you'd have a failure at line 1,000 and then you'd still get 5,000 more. We said, we're not dealing with that. So.
Yeah, so I guess part of me is wondering if I wanted to start with RackN is like how much work is involved.
With regard to that, most of what I showed is actually default content. So I've created a few wrapper content to help with like setting up the triggers and stuff like that. Yeah. But most of the rest of it is actually default content.
We worked really hard on that out-of-box experience to try and reduce the learning curve. So it's possible to take these things apart and really dig into it, but the out-of-box pipelines fit together very easily, and it becomes possible to just sort of connect and add from that perspective.
It looks amazing. So a question I have, which is a bit cheeky, is why isn't this already everywhere? Why aren't you bigger? Why have we not really heard of you yet?
We have been doing this for a long time. And this comes back to the history slide that we started with. We did focus on what we thought was the hardest problem, which was physical infrastructure, bare metal, on-premises data centers. And what we've been doing is actually working through those problem sets as we've made it better and better to do it. We've actually done hybrid cloud work. If you went back in our history, you would see we've done hybrid cloud multiple times for the systems, but always with a grounding in the physical infrastructure side because the problem space is so complex. What we've changed in this release and why we're hoping you'll hear a lot more of us is this addition of clusters and resource brokers as the core mechanisms are the things that we figured out are necessary to scale the infrastructure as code story. So this has been evolution for us in getting to a point where we felt, this is actually more about RackN than about the market, where we felt the way that we could help companies scale all of their infrastructure, we had a very concrete answer, and that has been battle hardened.
We are wondering how much of that is template content. You know, how long typically does it take customers to get up and running and actually deploy something into even test? Right. You know, how long does it take them to to become familiar enough to actually roll something out?
Yeah, so I guess there's to answer Justin's kind of question there too. There's a maturity level in some regards, right? As we've been watching our customers come in, the customer has to get to a point where they decide that's important. The specific of, I need a CI/CD pipeline. I can't just go emergency roll things out. I can't, right? Those kind of mindsets have to be a starting point to say, no, that's going to be important to us as an organization. Once that kind of mindset starts as okay, that's important, then we can get to okay, so how are you going to do that? What are you going to do? And so like a lot of the content that you guys are asking about exists. And so like we have pipelines, right? These are pipelines that know how to install bare metal Linux, right? Alma, CentOS, debacle, Debian.
Yeah, dealing with that a lot.
Yeah, ESXi, Fedora, right? We have example pipelines for that kind of stuff out of the box. So if you want that done, it'll happen.
And then you can clone that and customize.
Well, no, the point is, that's the starting point.
Yeah.
And from our perspective, you could clone it, but this is where part of me says the next step is actually, it's not about cloning, it's about using the extension points that are already in the system.
So you're providing sizable bricks with which to build.
Well, so like,
let me tell a little story with this, because Greg, we used to send Greg on site when in the early OpenStack days. So he would rack a rack of servers up, install OpenStack, build everything up. We'd ship the rack on an airplane, like it would be on the airplane, and he'd be in coach.
Holding it up the whole time.
And so
it was very cold.
So right, they'd land, they'd rack it up together. And what we found was that as soon as that happened, you basically forked the code. And every site was a snowflake. What we have done, and the reason why it's taken time to do it, is we have sat back and said, all right, how do we make it so that automation doesn't result in fork? And so what we do by design is when we build the infrastructure as code pieces, if somebody comes to us with something new, we don't consulting fix it or give them an ad hoc solution. We actually bring it back and turn it into code. And that code becomes these templates. And then what happens is, as the evolution of the things go, somebody says, oh, you know what, I need this flag turned on. And you're like, we didn't think anybody used that flag, so we didn't incorporate it in. We'll add it back into the template, and the templates expand. So what we're showing you, they are very, sort of this easy pipeline path through the system, but they are also the result of years of evolution of how these systems have.
No, I'll clarify. Nobody's expecting next install. Boom, infrastructure as code. Completely unrealistic. But is it a week? Is it a month? Is it a quarter?
We think they should be expecting.
Yeah, that we believe
like infrastructures.
You absolutely have to expect.
So the design here is the system should reward you for infrastructure as code behavior. if that makes sense.
Correct.
But let me be, you can install this on like an Amazon server and add in your credentials and have a broker running in like 20 minutes. Like you could start to finish, you should be able to get an Amazon cloud provisioning infrastructure, one in Linode or Google or Oracle, or we have a whole bunch of different brokers already wired in. And so you should be able to do that, 20 minutes, an hour tops, and the system should build that provisioning stuff out. That's really important that you get that experience, right? Now adding webhooks and learning how to build content packs, we actually have a content pack tutorial. It takes people about an hour and they learn how to build their own content packs and upload them into the system and go. And like if you look at our team and you look at what our customers do, they don't edit in this UX. This UX is an operational front end. They actually work in coding tools. They bundle things together, they upload it in, or now with the GitHub, the Git integrations, they'll literally just commit and then let things get deployed out to the systems.
Obviously, anything involving infrastructure, you're touching VMware, you're touching multi-cloud platforms.
Yeah.
How are those templates updated? Are they coming through from Git updates from a source on your side? If VMware update and something changes and it breaks a template, how long is it from that gets resolved?
Yeah, so OSs are current.
Sorry, I'm just giving real.
CentOS, for example,
I love the question because it's this is life, right?
Yeah.
CentOS is a bane of our existence right now. And so, for example, we have our content packs, and so we break out a lot of our content into various subcomponents. And so they're grouped, and so we can generate new updates for those as changes occur and immediately publish them. So for like the CentOS issue, in fact, so the Rocky team decided that they were going to get rid of all 8.4 ISOs in the internet. Okay, so that meant that our 8.4 install environments don't work now. So we published, within hours of that happening, an update that went out into the product stream so that you could update and get.
But the point I'm making is you don't have to go through an update mechanism. There's some automatic.
So
we should talk about that.
Okay, yeah. So you can make it automated on our side to go scan,
push,
and get that. In general, we try and not push, mostly because of firewall issues and other things like that, and we want them to be in control of what their content is, right?
Customers get picky if things change in their operation.
Yeah, so financial institutions don't really like things being pushed to them, right?
No.
Right? So in that regard, we let them define when they want to pull it in, and then using, which we talked about.
That's the answer.
Well,
that's all I need.
There's another piece.
There's another piece, though, on our side, which what we call an object is a version set. And a version set represents the complete configuration of a DRP endpoint down to the specific content version and even files that need to exist on that system.
Now you've got a merit. That's all. This
that is actually the design.
There's multiple options available. We can do either.
Yeah.
And
that's all.
That's critical. And the thing that's transformative for our financial services customers, actually for all of our customers doing multi-site work, is they can say exactly what version of the software of all the pieces, because it's modular. It's not just Digital Rebar. Digital Rebar has a whole bunch of modular plugins, binary plugins, content pack, like it's composed. And the reason it's composed is because then you can take a site and you know exactly what's in that site. And you could do a continuous deployment rollout across your fleet, which our customers have to do. So they can take their dev site, right, test it. They have a staging site. They make sure things work in staging. They can go to one data center, roll it out, and they actually know that they're exactly replicating their automation. And this is groundbreaking, right? They know exactly what they've done in each site.
Anyone who's tying this in with their operation is most likely some kind of service provider. They have SLAs to their customers. So anything that reduces downtime for them and their SLAs to their customers, that can be leveraged as part of this product is important.
If we choose, I would expand the definition of that to also include like enterprise internal providers. So for like our financial institution isn't an MSP, but the groups we're working with effectively are that kind of group inside the bank where they're providing resources to other teams on demand and so they have SLAs and stuff.
And platform teams are going to have the same.
It's basically a platform team, right? One of you asked about what is our content. So like, this is a workflow. This is our universal discover workflow. It's run usually as the first element of every single pipeline. It's made up of stages, which are just collections of tasks. And in this case, we do a bunch of like discovers. We give you the ability to do callbacks. So this is a programmatic, configurable way to extend, to generate notifications to systems. So like the telco we were mentioning uses it to indicate that a site's showing up for the first time, right? So that callback calls to a system to generate saying this is coming up. We give you the ability to inject your own tasks that are outside of our base set at the beginning. And then we build through a set of things that we're always going to do, right? We're going to do some basic inventory. We're going to, on physical systems, figure out what the RAID configuration is, inventory it. We'll even try and inventory the baseboard controller to figure out if it's configured, what it might have, right? What its BIOS settings and configuration might be. We'll even do LLDP discovery so that we can figure out how it's attached to the network, right?
And these are all built in. So you can skip them if you want, but the right behaviors, and this is one of the things that to me has become really important with the automation pipelines. Like our VMware stuff, our VMware pipelines work to bank standards. But if you're not a bank and you turn them on, it'll skip over all of the security protocols and the out-of-band management protocols and the certificates and all that stuff, but it's there.
And it's on by default?
Yes.
The right things are on by default, and the things that require additional configuration, you have to add in from the system. The way the pipelines work, and it's nice to have some time to explain this. Digital rebar is a state system, right? And so it collects the state of your infrastructure progressively. We actually use patch a lot when we were collecting. So we actually can take updates from our own system, but we were designed to take updates from other systems. There's no state file somewhere that's going to get botched or lost or in the wrong hands. It's actually in the database. We can take new information in and keep going. And so when you're running a pipeline, what you're literally doing is collecting more and more data. Could we bring, oh, you have it. We're collecting more and more data about the systems that you have, and then that in a dynamic way using params. So you can actually say, oh, I need this data that I didn't have before. You can add it into the system and then influence downstream operations dynamically as that's discovered. So we don't assume like it's not an Ansible inventory file where you have to know everything in advance. It's actually designed to know nothing, learn and go. And then all these things cause events, and there's a whole bunch of pieces in here. Did you want to add?
Yeah, so like in this case, I'm looking at that crypto machine that we built, right? We detected it was a virtual machine. We inventoried it. We see what it's apparently running on a QEMU hypervisor. It's given us this kind of much fake memory, right? All that kind of stuff, emulating that kind of processor. We even can get your traditional Linux style memory layouts and stuff like that.
And how cloud, and we have
cloud infrastructure pieces, right? And then if it's on a physical system, we'll also get things like the RAID, BIOS, other configuration based upon tools installed. And then the point is that part of the pipeline will drive the system to what we call a classification step. And by default, the classification step may choose to do nothing, right? We'll just put the system into an idle pool. Or like the banks, they choose to do serial number based definition. So they already say like, this serial number is going to join this VMware cluster. Okay, and we'll go, okay, great. And so we'll catch that serial number, match it, and go, oh, well, let me add these 8 profiles, which will then change the task list in the pipeline dynamically to say, okay, we're now going to do hardware. And this is where the team thing becomes very powerful. So we were talking about the crypto team. Well, you actually have teams on the quote underside as well. So you have a hardware team who's responsible for going, you know what? I'm going to install ESXi 701. That means I need a Dell 740 with this set of BIOS settings and this firmware and this RAID configuration. But if it's an HP system, I need this other set of firmware with this other BIOS settings and stuff like that. The same profile system that we have works for that team as well, so that they can provide a content pack that's targeted specifically for those specific hardware and components, so that they can just be responsible for, okay, that's what needs to be put on the system. And then all the rest of the pipeline continues on, and the ESXi team can say, well, okay, yeah, you guys took care of that. I need a VLAN, right? I need it to switch to this for networking, right? And those are separate parameter spaces that are maintained by the two different teams, but in an infrastructure as code way, so that they can achieve both sets of goals, right?
So with all this configuration information that you're gathering over time, I'm assuming you're timestamping and keeping it over time. Is there like is there functionality or ideas towards functionality, or is it just kind of you can do it? Yeah, it's there for like config drift.
Oh boy.
Or and even take it to the next step in remediation of config drift.
Yeah. So
to a good state.
Strangely enough, we actually don't keep it timestamp like that. We generate an event stream so that that's possible. The reason we don't is we're also targeting those switches, right? And I don't necessarily have the storage to store that, but I can generate an event stream that could be stored in like an Elasticsearch and then drive all that kind of stuff to do analytics or AI after the fact and that kind of stuff, right?
We have a standard plugin for
FileBeat that will push all that stuff
out.
Right.
Okay, so you externalize that information.
Yeah, it turns into a scaling choice of we could build it in, but since we're also trying to target these edge locations, it
can grow real fast.
Yeah.
Okay.
So it's a balance, but it's not something we're opposed to. In fact, we have some content packs that will actually spin up a target to receive events, right? So it's
and then theoretically you could have one to pull that information back in. If you
right. Exactly. Right. But somewhere else I wanted to go with that.
Okay. Oh. I had another. So I was going to pull back and can you create a cluster for me in a cloud somewhere, just a Terraform cluster?
Maybe.
Yeah, this is great. So what the thing that I also want to draw a point on, because we're talking about sort of the metal and bringing up a machine and running it through a pipeline. There's something we're doing that's really unique in the Terraform orchestration space also, which is when you run Terraform, it actually detects that you've created machines in Terraform, builds them in digital rebar, even before they're spun up in the cloud, and assigns them to a pipeline for execution. And this is one of the big gaps in how Terraform and what people are doing, mixing Terraform and Ansible together or writing their own scripts to do this. What we're actually able to do is when you run the Terraform, and that's creating machines or deleting them, we're able to, we catch that, we create a machine, and then that machine has its own pipeline. And so that means that I can take, as I build a cluster out, I can say, okay, I'm building a cluster with 6 different machine types in it, and each one starts with its own pipeline definition, its own task actions. So right in Metal, we get the discovery, and then we can classify it and do all this work. In Cloud, we're actually starting at a further point down the stream, but because we've created a pipeline for each machine that you're managing, we actually have a lot more control than other Terraform integrations to provide that downstream action. And so I can see it. Like that's one of the nice things about this is I create it with Terraform. I'm not inspecting the file. The product actually shows you and then starts running all of the workflows that I want on the machines I just created. Because of the cluster is a separate construct with its own pipeline, you can build clusters, and our clusters will do this by default, where it waits for all the machines to get provisioned and online and ready, and then you can do additional operations on the cluster. That's provisioning, and then flip the cluster to workflow mode where you can take additional operations on a cluster as a day 2 action, where you could like re-spin all the certificates.
And an example of that is our kubespray setup. In fact, when it creates a node, it runs the Kubernetes kubespray base pipeline, which has a task, which is the specific requirements that are required to run Kubernetes on a node. So it knows to turn off swap, for example, turn on IP forwarding, right? Those are requirements that all nodes in the kubespray cluster have to have. So that's built into that pipeline. So just joining that cluster, that pipeline's applied to any machine. And then there's a pipeline for building the cluster, which lets you define and synchronize all of the events that you need to bring up the cluster.
Couple of questions that are, here in our back channel. So one is, so the licensing model, and I had also, the number of customers that you have and a description of the small customers. I mean, when they find, the advantage, because there is some work that you have to do to implement all of this. So when is the minimum size of the customers, and don't tell me 10 nodes. So
no, that's fine. I'll try and answer them in order. So licensing model, it's a software package that people license on an annual basis. We do have some monthly options for people who want to be strictly activity-based. Most of our customers pay per machine. There's two types of machines. So we have one price for virtual machines and clusters and brokers. So those count as virtual machines, and another price for physical machines. It's about 4 times more expensive in our platform to have a physical machine because we have a lot of extra functionality for those.
But the physical machine license will cover a host?
Yes.
Okay.
It doesn't cover all the VMs for a host.
Okay.
We do not try to figure out like these VMs are on this host. If they're entities that are managed in Digital Rebar, we count those.
What about containers?
Sorry?
Containers?
The containers that we spin up and manage also count as a virtual machine. Each one. The way I would think of it, it's equivalent, like the cluster or the broker, those are equivalent to a runner in some of the Terraform orchestration, or they have an activity-based licensing model. We don't do that. We're trying to keep it very simple. If you have a runner, a broker, you're gonna pay for the opportunity to run work on that.
And then as you go increasing scale purchases, there's discounts for scale.
Right. The next question was we have
number of customers.
We have 25. We keep adding, so about 25 customers and growing. From that perspective, and the range of our customers is dramatic. We actually have customers who are 10, 15, 20 machines. It's, the amount of automation we do is valuable even at that scale. And then we have customers in the 20,000 range where we're their global deployment pieces. So very, very broad. And most of even our big customers usually start in a small. That's very typical. And the licensing is worth noting. We've made it very easy to download and try. So if you download and try, you'll get a trial license. The licensing is actually you get a file. So we're used to air gapped behind the firewall customers, and so customers get a file and they're completely autonomous from that perspective.
Really nice how you obviously put an enormous amount of thought into this, and it's just obvious to me that you must have had a lot of, well, what if this happens? And taking it from a real world situation report of going, an outlier, maybe, what would happen if this happened or that happened or this happened, but from the perspective of, oh, geez, what do we need to do now? Because there are so many moving parts here. Just in the Kubernetes or bare metal server environment, you haven't even, most people don't even think below that layer. You just think it's magic. And it's not.
I appreciate that. One of the things that we do that's really unique is we assume heterogeneity. And so we didn't start from the idea that all of our customers would follow our patterns and buy our servers. Like, we're not an HCI solution where it's like, well, as long as you buy this model of Dell, then our software will work. We started from the opposite side of the spectrum and said, our customers have data centers that they operate. They're going to bring everything to us.
Right.
And so you're right, but that's a very important thing for us as we look at the environment, to not figure out how we constrain our customers, but how do we respond to our customers?
Yeah,
right.
The other aspect I would add to that is a lot of our customers, this is not what they make money at.
Right.
So it's a cost. So things that help them reduce this cost are valuable to them. And part of that means that when they discover something that doesn't work, they are really incented to say, yeah, this didn't work. Can you fix it so that I don't ever hit this again?
Right, because that keeping the lights on thing that consumes so many IT people's constant lives. Just pure tedium that, again, with whatever.
That's right. And so part of the system is designed to say, okay, we've automated this. Let's do this the right way and consistently.
Exactly.
And then we can keep iterating and then pulling that in.
And to have a framework to automate the automation is quite intriguing.
Yeah. So we appreciate your patience, attention, and questions. What we've really worked to show here with the bank-end cloud example, and that code is available for you to look at and inspect, is that you can operate infrastructure as code at enterprise scale. That there's actually techniques and processes and ways that you can approach this to do the collaborative work that's necessary for scale. We did show you in the demos that we could take a bank style customer, so the most rigorous demands, very heterogeneous and dynamic infrastructure, pull that together into a single platform, and then allow each team to actually have its own unique controls. So we had both unique controls and rolling back where security could apply a fix across the entire distributed fleet. We would encourage you to try this yourself. Everything we're showing is actually an easy download. You can plug in your cloud credentials and you can replicate these settings, even down to the multi-site management pieces that we build. You can go in and repeat those experiences yourself because it's infrastructure as code. So please download and try. This is something that we want to collaborate with you on, and we get better, and the infrastructure as code systems get better. The more people come in, the more we ask, the more we repeat and improve. So thank you very much. We appreciate your time and attention.